First, let me give an overview of peer-to-peer systems. So to start, we'll define what is peer-to-peer computing. So let's look at several definitions. The first definition is by Oram. This is one of the original definitions of trying to define what it means. So according to this definition, peer-to-peer is a class of applications that takes advantage of resources available at the edge of the internet. The edge is the logical opposite of the center, which is the data centers. Also, because these decentralized resources means operating of an environment of unstable connectivity and unpredictable IP addresses, peer-to-peer nodes must operate outside the DNS system and have significant or total autonomy from central servers. So this is a very strong, extreme definition of peer-to-peer. Another definition, later by a peer-to-peer working group, which is a standardization effort, this definition is more general and less extreme. It's the sharing of computer resources and services by direct exchange between systems. So the nodes exchange directly without going through a server. So it takes advantage of existing computing power to allow clients to leverage this power to benefit the entire enterprise. So the idea is to take advantage of the existing computing power and not need the cloud. So after these definitions, we have the following definition, which is trying to make it more general as possible and also not being too constraining. So the first part is that we have resource sharing. The second part is that all nodes are both client and server. There's no specific clients and servers. The third part is decentralization, autonomy, so that the nodes do not have to go to a central authority. The fourth part is scalability. It should be possible for the number of nodes to increase without unduly increasing the load. And also a notion of robustness or self-organization. If nodes are failing or leaving and coming in, the system should keep working. So this is the kind of definition we're going to be looking at. And there have been several generations of peer-to-peer systems. So the first generation is a system called Napster. This was the first very popular file sharing system. So the nodes here are nodes containing the files, would talk to each other directly in peer-to-peer fashion, but the directory, the information of which file was stored where, was still stored centrally. So this is not a 100% peer-to-peer, it's partially centralized, even though the file exchanges are decentralized. So the second generation is where we do not have a central directory anymore. All the nodes have a directory and a file store. So if I'm at a particular node and I want a particular file, if the file is not local, I will send messages to neighboring nodes, and these will send messages to more neighbors. So I will use a flooding technique. I will flood the system to find out where is the file. And once I find out where the file is, I can do a direct peer-to-peer exchange. So these were famous systems called Nutella and Freenet that use this approach. And this approach is completely decentralized, and it's basically unkillable because there's no way to destroy the system. If you remove some nodes, the other nodes will just keep working. But the problem of this is still inefficient because we have flooding, we have a random overlay network, so that there's a lot of superfluous messages. Now we have the third generation. This is a peer-to-peer system where we add structure. This is called a structured overlay network. It's also called a distributed hash table, or DHT, because that is the most common abstraction that's built. So if we have a set of nodes here on the left, they're organized together and they behave as one system, and you can query the system. You can do a get or a put, and you can put in data and get results. So there's an interface which is very similar to a hash table. We have a put operation and a get operation. So put key value. The key could be, for example, the name of the file, and the value could be the content of the file, and get key will give you the value corresponding to the key. So the neighbors here are well defined. It's not random. A value inserted from any node will be stored at a certain well-defined node. So the nodes are structured and organized among themselves. So the question, how do we do this? Well, the basic idea is that there is a single identifier space, a common identifier space that are, for example, 32-bit, 64-bit values, which are identifiers. And we have the set of nodes, and we have the set of values. The nodes each have keys, and the values each have keys, and they're both existing in the common space. So that means each computer has its own ID, but each file has its own ID. And so we can have some kind of a clustering where the file IDs that are close to a particular computer will be stored there. So if you look at the common identifier space, you have both nodes and values here, and they're both in that space. So the values that are close to a particular node will be stored there. And that's how the system gets organized. You see these values here, the yellow squares, will be close to the dark circles, which are the node identifiers. So that's the logical way of organizing it. And then the idea is that you connect the nodes in a smart way so you can do some kind of a routing between them and find the files. And this is what leads to distributed hash tables.